Okay, here's the fire spirit demonstration. First of all, I would like to thank whoever made the Greenwood Village Acid Pack on the Epic Game Launcher. This is a beautiful village, great cartoon graphics. I'm in love with them. Now, the premise of the game is to be a fire spirit and to not burn out. It's very, very simple. It was my game 207 course, so a sophomore level course, and that was when we were just learning blueprints, so it's very nice to be able to visit the game. Back then I had a computer that was not able to run Unreal Game Engine for whatever reason. Let me clarify, it could run Unreal Game, but it wouldn't load the geometries, textures, and I tried a lot, and I tried to get professors to help, and I scoured the internet. But 2 years later, I'm able to have an i9 and 64 gigabytes of RAM and a really amazing video card. So it's an incredible experience being able to run Unreal Game Engine 5, like, boom, blink of an eye, everything's up and running. Alright, so go ahead and show the basics. Here's the fire spirit. Right away, there's these water spirits. They're the spheres, very prototype-like graphic for it'd probably be nice to have raindrop more like pronounced blue, kind of like these butterflies but blue, and have like particles dripping off of them. It's a pretty idea for that, like these flowers here. I'm going to go ahead and show the AI for these water spirits, but first I want to demonstrate the torch. So you'll have the water spirits following you, and then you can jump into the torch and you can see they're no longer following. And then the torch runs out and they jump back to us. Just torch over here. Ooh. You can see, alright, this one kind of got too close. I don't know why the third one did. Some debugging definitely needs to occur. Let's check it out. So here we have the AI water spirit controller, the blackboard, and the behavior tree. This is very simple, very simple. We'll go ahead and jump. Here we have our root sequence, which allows us to run tasks, and move to. It's going to move to our target. The target is going to be the player. If we go to the blackboard, we can see that we have a key. It is our target. It's an object. That's the key type. It's important to change the base class to actor. If it's not set to actor, this won't work. Here, if we go to the blueprint water spirit, we can see that when we overlap the third person character, we have to make sure that the object is the third person character. If it is, we're going to set that target value. And it is able to access the blackboard by going over here and making sure that the default controller, because it is a pawn, it can be possessed by a controller. So here, controller, you can see that the AI controller class is indeed the water spirit controller. You always have to have a navigation mesh, so here you can see this navigation volume, and you can see the collision sphere for the water spirit. It's rather big. Go ahead and show the controller. Controller is really simple. I had a strange bug where I was thinking that this run behavior tree would work if I was overriding the on possess event, but it wasn't working, so it made a lot more sense to use begin play and then run the behavior tree. I like how simple and straightforward it is. The distance formula, again, rain's all, we're always checking to see our distance and changing our states. Again, when I'll show the torch code for a moment. But that is the AI. We have the water spirit, the AI controller, our blackboard, that's our data, and then our behavior tree, which allows us to act on that data. Here we ask, do we have a valid torch? So if it is true, if it's false that it's empty, excuse me, if the torch is equivalent to an empty object, that would be true, so we're not going to do anything. If it is false, that is not an empty object, then we have a valid torch, and we can enter the is zooming state. So we set this to, sorry, this is a little bug, so this should be true. Change that. Go ahead and test this real quick. Alright, that was better logic. Sorry about that. So again, when we are zooming, we're going to be in the zooming state, and then we're going to branch based on that. I wanted to set the collision to none, and this way, as we're zooming to the torch, we're not getting caught up on any physics meshes, which, it's nice. If it's in the game, and again, the whole fire spirit idea is it could catch things on fire, and it's like, okay, this is a benevolent fire, it's not catching things on fire, it's only trying to survive kind of thing, but everyone else is trying to turn it out because it thinks that it might catch things on fire. Maybe there's a probability that it does on accident. That's in regards to the collisions, it's colliding with wood and things like that. But when it's zooming to a torch, this could end up with strange behavior, it going through walls and things like that. So it should be on a path between the object that it's trying to zoom to. So this is just prototype, so it doesn't get caught on anything. We have our valid torch. And because we have our valid torch, this is, I guess, a precaution why I did this. This may be legacy before this was implemented here, but it's always good to know that the torch is still a torch, and we can get the actual fire on the torch and get that location rather than getting the entire torch with the stand and the fire on top. So here we can, with precision, move to that location where the fire is located. And this is our third person actor location. We're going to lerp between them. This timeline has a value at here, 0, 0, it's smooth. And it's going to go for about 5 seconds, and then it's going to get to 1. I think that this could be changed to, smooth out, zoom to it, things like that. It could be played with. Now, once it's finished, we're no longer zooming. And when it is finished, we have to set the collision enabled back to, I put it back to query in physics. This is, from what I understand, the best place where everything starts, the base case. I need to revisit the query in physics system, which I plan to in the C++ version of the Vampire game. We'll see where that goes. Because, it's just a huge brick of C++ code when it comes to enabling the collisions. It's pretty nice to get to see that fine-grained interaction. And Stefan Ulibarri, forgive me, Stefan Yu, he has a really good C++ developer book with Unreal Game Engine, and that completely clarifies a lot of things. It's very nice. Okay. Here's the actor location. We set that as the lerp is going through. So, yep, this is the fire spirit code. If you have any questions, feel free to let me know. The whole thing took about an hour in retrospect. I was working the front desk at my other job, so it took a little bit of time. But this is actually, I came home and redid it on my desktop. I do have a prototype that I did at work on my laptop. So this probably took about an hour to 30 minutes to double check everything and put it back together. Cool. Further additions are going to be draining the fire, having the burning health go up as it's in the fire, having campfires, probably lighting these buildings on fire, and kind of just exploring the elements. I really believe in game development, especially in the beginning. In all games, it's really important to have everyone grounded in, the understanding that, all right, despite the game, we always have this strong concept of water, fire, earth, and wind. I'm not trying to go back to any like Avatar anime fandom. It's just like I believe elements to be a very fundamental understanding to video games in general. And then you have this human aspect, and we go much further. It's not just elements, but it's nice to have a game centered around that exploration. All right, thank you.